Now, first of all, I would like to know whether you know about isomerism or not. Can anyone explain what are isomers? Can anyone explain what are isomers or isomerism? Tell me. Can anyone say or write what are isomers or isomerism?
Same formula but different structure.
Different structures. No, no. First, two or more than two compounds. Two or more than two compounds which have same molecular formula. Same molecular formula. Same molecular formula. Two or more than two compounds which have same molecular formula but have different physical and chemical properties. Physical and chemical properties. Physical or chemical properties, physical and chemical properties. It may be different in physical, but it may be different in chemical or both. Two or more than two compounds which have same molecular formula but differ in physical and chemical properties are called as isomers. When molecule have same molecular formula but different in structure, then you are restricted to structural isomers. You are restricted to structural isomers. So you should not make any restriction. You should not make any restriction. So definition is when two or more than two compounds which have same molecular formula but differ in physical and chemical properties are called as isomers. Take this example. C2H6O. C2H6O. You can make a structure CH3CH2OH. You can make a structure CH3CH2OH. You can also make a structure CH3OCH3. You can make two structures for this molecular formula C2H6O. When you carefully analyze, you will see that in this case, this is called as ethanol. This is called as ethanol. Functional group present in this compound is alcohol. Functional group present in this compound is alcohol. Alcohols are those compounds in which OH group is directly attached with sp3 carbon. sp3 carbon, this compound is called as alcohol. This is ethanol, and this compound is methoxymethane. This compound is methoxymethane. Methoxymethane. This is the ether. This is the ether. Is it clear? Do you know the attachment? This is called as alcohol. This is called as ether. Is it clear? Tell me.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now look over this. This compound, this ethanol, also has molecular formula C2H6O. This methoxymethane also has molecular formula C2H6O. But here in ethanol, oxygen is directly attached with hydrogen. And when oxygen is directly attached with hydrogen, this hydrogen is considered as acidic hydrogen. This hydrogen is considered as acidic hydrogen, and there is test of acidic hydrogen. Do you know what is the test of acidic hydrogen? Tell me. How can you identify whether hydrogen is attached with electronegative atom, oxygen, sulfur, nitrogen or not? This is the test. Do you know any test of acidic hydrogen? Because you have learned about the concept of acid and base. Tell me. Do you know?
Sodium metal.
Sodium metal. Very good data. Sodium metal. Any compound in which electronegative atom is directly attached with hydrogen can be analyzed by adding sodium metal. By adding sodium metal. If sodium metal is added to a reaction container or any chamber or any container which have electronegative atom directly attached with hydrogen, in that case, hydrogen gas will be evolved. So if this ethanol is taken into a container and if I add sodium metal over it, then hydrogen gas will be liberated. This indicates that this ethanol has acidic hydrogen, or a liquid which I have taken in this container have acidic hydrogen. But if I will take this methoxymethane into this container and add hydrogen sodium metal over it, then no hydrogen gas will be liberated. So the nature of chemical reaction of this ethanol and nature of chemical reaction of this methoxymethane are different. So there is a difference in chemical reaction. So there is difference in chemical reaction, but molecular formula is same. Here, when hydrogen is directly attached with oxygen, there is possibility of hydrogen bonding with other alcoholic group. But here, carbon is attached with hydrogen, so there is no possibility of hydrogen bonding with any other atom or this ether. So, if hydrogen bonding is present over this ethanol with other ethanol molecule, then its boiling point will be higher as compared to this methoxymethane. So there is difference in physical property of these two in terms of boiling point. There is difference in chemical reaction in terms of sodium metal. So they have different physical properties. They have different chemical reaction, but they have same molecular formula. Then what you will say? When two compounds have same molecular formula but differ in physical and chemical properties are called as isomers. I think definition is clear to everyone. Is it clear?
Yes, sir.
Now,
Yes, sir.
these isomers are further classified. These isomers are further classified into two types. These isomers are further classified into two types. First is called as structural isomers. Second is called as stereoisomers. First is called as structural isomers. Second is called as stereoisomers. Can you define which compound is called as structural isomers? Can you define the definition of structural isomer? Anyone? What are structural isomers? Anyone?
When two or more than two compounds have same molecular formula but different structures.
Very good. This is the definition. When two or more than two compounds which have same molecular formula but have different structures, when they have difference in connectivity, when they have difference in attachment, they have difference in IUPAC name, then they are called as structural isomers. Like I have taken the example, this is ethanol. This is ethanol and this is methoxymethane. The IUPAC name of these two compounds are different. The IUPAC name of this compound are different. The connection here, oxygen is attached with hydrogen and carbon. Here, oxygen is attached with carbon and carbon. So when structures are different, when connections are different, when IUPAC name are different, then such isomers are called as structural isomers. Is it clear? Is it clear?
Yes, sir.
When structures are different, when connections are different, when attachments are different, when IUPAC name are different, then such isomers are called as structural isomers. These structural isomers are further categorized into 5: chain, positional, functional, metamer, and tautomer. Have you heard about this? Chain, positional, functional, metamer, and tautomer?
Yes, sir.
Yes, sir.
Now, can you define what are chain isomers?
They have different size of main carbon chain.
Okay. Only main carbon chain or any other thing also?
Or side alkyl chain.
Side alkyl part. Very good. So you have to know, you have to remember two things. Chain isomers are those structural isomers which differ in main chain or side chain. Two things which you have to analyze, which you have to understand. Main chain or side chain. Main chain or side chain. Main chain may be methane, ethane, propane, butane, hexane. Side chain may be ethyl, propyl, methyl, pentyl, hexyl. If I'm taking the example, this is butane and this is isobutane. The number of carbon in the main chain is 4. Here, the number of carbon in the main chain is 3. So they are chain isomer. If I will take example like this is cyclopropane, here ethyl and here dimethyl. In first case, there is no difference in main chain. There is no difference in main chain, but here the side chain is ethyl, number of carbon 2, but here side chain is methyl, where number of carbon is 1. So if there is a difference in main chain or if there is difference in side chain, then such structural isomers are called as chain isomer. Is it clear?
Yes, sir.
Now, second one is the positional isomers. Can anyone define what are positional isomers?
Two two or more isomers which have different position of functional groups or locants or multiple bonds are known as positional isomers.
Good. If you are saying locant is simply the position, beta. Important is there is difference in position of, location of. Location means locant. Location means position. When there is difference in position of functional group, difference in position of multiple bond, difference in position of substituent, then such structure isomers are called as positional isomer. Like if I will take 4 carbon like this, if I'm taking 4 carbon like this, 4 carbon like this, if I will place OH group over this carbon, if I will place OH group over this carbon, the position of functional group here is 1, the position of functional group here is 2. So there is difference in position of functional group. If I will place position of double bond over this position, if I will place position of double bond over this position, so there is difference in position of double bond. It may be triple bond. If I will place position of Cl over this position, if I will place position of Cl over this position, so there is a difference in position of chlorine, there is difference in position of substituent. So there are only 3 things whose position can be different. They may be functional group, they may be multiple bond, they may be substituent. But there is limitation. There is no change in main chain or side chain. There is no change in main chain or side chain. There is main chain, side chain remains same. And if there is position of functional group, position of multiple bond, position of substituents are different, then such structural isomers are called as positional isomer. Is it clear?
Yes, sir.
Now, what are functional isomers? Anyone who can explain what are functional isomers?
Different functional group.
Very good. Differ in functional group, differ in nature of chemical reaction. The functional isomers are those which differ in functional group. Look over this. I have taken ether, I have taken alcohol. So both functional groups are different. So these are the example of functional isomer. Aldehyde ketones are functional isomer. Alcohol ethers are functional isomers. The functional group difference means functional isomers. What are metamers? Anyone? What are metamers?
When two isomers have same functional group but have different nature of alkyl group attached to the heteroatomy, then these are called metamers.
Metamers. One more thing, beta. Heteroatom must be polyvalent. You cannot take hallucin. Okay? If there is any type of difference along polyvalent atom in carbon, it may be nitrogen, it may be oxygen, it may be sulfur. But you cannot take halogen because valency of halogen is 1. If along polyvalent atom, any type of change in carbon are called as metamers. Like if I will take ethyl, here ethyl, if I will take propyl and here methyl. Here in this case, in the oxygen, here 1 carbon, here 3 carbon, and here in this case oxygen, here 2 carbon, 2 carbon. So if number of carbon are different, if position are different, any type of change, then they are called as metamer. Any type of change along carbon, along polyvalent atom, keeping functional group remains same. It is important. Keeping functional group remains same, then such isomers are called as metamers. Is it clear? Is it clear?
Yes, sir.
Now, what are tautomers? What are tautomers? Tell me. What are tautomers? Have you read this? Tautomers? Keto enol tautomerism. Have you read this? Have you read tautomers? In electronic effect, I think you have made structures like this. You have made a structure like this. This is keto form, and this is enol form. So when position of hydrogen it changes from 1 to 3rd position, when position of hydrogen it changes from 1 to 3rd position, then such dynamic equilibrium can exist. And when 2 or more than 2 structures are in dynamic equilibrium with each other and there is difference in position of proton, then such structural isomers are called as tautomers. There is 2 requirements. First is molecule must have at least 1 electronegative atom and it should be multiple bonded. And second is alpha position must have at least 1 hydrogen and alpha position must be single bonded. any compound if fulfill these two requirements, then such molecule will show tautomerism. Is it clear?
Yes, sir.
Now, the important 12th class segment is starting from this stereoisomerism. 12th class segment is starting from this stereoisomerism. How can you define stereoisomers? Anyone? How can you define stereoisomers?
Molecular formula and same structural formula.
Molecular formula, same structural formula. So when both are same, then how can you differentiate? Both are stereoisomers. Like I'm taking the
Different
example.
stereochemical formula.
Stereochemical formula. What are stereochemical formula, beta? What are stereochemical formula? Like I'm taking,
Orientation in the space.
yeah, that is the thing. Look over this. It will help you in defining the definition of stereoisomers. Look for this. What is this? What is this? What is this? Hand. What is this? Hand. What is this?
And
Hand. So this is hand. This is also hand. But this is different. This is different. I can write with this hand very much faster as compared to this. The characteristic of this hand is different and the characteristic of this hand is different. So they both are hand. That means IUPAC name are same, but difference in orientation. Difference in orientation, they are the mirror image. Difference in orientation. And if molecule have same IUPAC name but difference in orientation in space, then such isomers are called as stereoisomers. Here, both alkyl groups are on the same side. Both alkyl groups are on the same side of carbon-carbon double bond. But here, both alkyl groups are on different side of carbon-carbon double bond. The orientation of methyl group in these two cases are same or different? What you will say? The orientation of this methyl group is same or different? What you will say? Tell me. Orientation are same or different?
different.
Different. That means stereoisomers are those isomers which have same IUPAC name but differ in orientation of atom or group in space. Now, these are the topic of 12th class. Now make a notes properly. Write the heading stereoisomerism. You have notebook now? Everyone have notebook?
Yes, sir.
Yes, sir.
Now write the definition. Write the heading stereoisomerism. First write the heading stereoisomerism. First of all, write the heading stereoisomerism. And now in stereoisomerism, write the definition. Write the definition. Stereoisomers are those isomers which differ in atom or group in orientation in space. Orientation in space. Stereoisomers, those isomers which differ in atom or group in orientation in space. Important thing, they have same IUPAC name. They have same IUPAC name. IUPAC. I will pronounce IUPAC name. On the basis of this, you can categorize whether the molecule is structural isomers or whether molecule is stereoisomers. If IUPAC name are different, then such compounds are called as structural, but IUPAC name are same, then such isomers are called as stereo. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
Now these stereoisomers are further categorized into two parts, configurational and conformational. Make the structure like this. Stereoisomers is divided into two parts, configurational and conformational. Right in notebook, stereoisomers are of two types, configurational and conformational. configurational and conformational. Configurational and conformational. Now, configurational isomers are true isomers. When you have to study about stereoisomerism, that means we are focusing mainly on configurational isomers. They can be isolated. They can be isolated by physical or chemical mean. But conformational isomers are not true isomers. Conformational isomers are not true isomers. They generally arises by rotation along carbon-carbon sigma bond. They generally arises by rotation along carbon-carbon sigma bond. So they are not true isomers. The true isomers are configurational. True isomers are configurational, not the conformational. So look, so write something below this for configurational isomers. Right? They are true isomers. Configurational isomers are true isomers. And they can be separated. They can be separated by physical or chemical mean. They can be separated by physical or chemical mean. Physical or chemical mean. But conformational isomers are not true isomers. Conformational isomers are not true isomers. They just arises. Due to rotation along carbon-carbon sigma bond. Arises due to rotation along carbon-carbon sigma bond. Right. Is it clear? Is it clear?
Yes, sir.
Now,
Yes, sir.
Yes.
now this configurational isomers are further divided into two types: geometrical isomerism, geometrical isomers, and optical isomers. This geometrical isomers I will see in small GIE, and this optical isomers I will see in small OI. The configurational isomers are further divided into two types. First is geometrical and second is optical. Write it down. Write it down. Configurational isomers are of two types: geometrical isomers and optical isomers. Geometrical isomers and optical isomers. Completed?
Yes, sir.
Yes.
Now moves to geometrical isomerism. Write the heading geometrical isomerism. Write the heading geometrical isomerism. Geometrical isomerism. Now first think for the concept. Think for the concept and what are the conditions for a molecule to show GI. Because in organic chemistry, infinite molecules are possible. In organic chemistry, infinite molecules are possible, and it is very hard to remember each and every molecule. So there must be some concept behind that. There must be some concept behind that. So first, for any molecule to show geometrical isomerism, first of all, think for the concept. I will write in notes form. First, think for the concept. For a molecule to show geometrical isomerism, molecule must have restriction in rotation. First condition is molecule must have restriction in rotation. Restriction in rotation. Molecule must have restriction in rotation. Those compounds which have restriction in rotation, only those molecules will show geometrical isomerism. If molecule will not have restriction in rotation, then such molecule will not show geometrical isomerism. Then question arises, which molecule will have restriction in rotation? There are two types of bond. One bond is sigma and one bond is pi. Think whether sigma bond have restriction in rotation or not. Tell me whether sigma bond have restriction in rotation or not.
No.
No.
No,
No.
sir.
Think for
No,
this.
sir.
Think for this. If I'm taking this mobile and this particular think as a nail. If I will place a nail over this mobile and rotate, it can be rotated. मतलब along sigma bond, mobile can be rotated, bond can be rotated. But if I will place another bond, another nail over this position, and two nails are present in this. So now, can rotation be possible? Now, can rotation be possible?
No, sir.
No, sir.
No, sir.
That means if a molecule has sigma bond, then it has rotation. It has free rotation. But if a molecule will have pi bond, whether one pi bond or two pi bond, if molecule will have pi bond, it has a restriction in rotation. If molecule have pi bond, then molecule have restriction in rotation. Now question arises. Only pi bond. Is there any possibility that sigma bonded system also have restriction in rotation? Now, answer is ring. Think for the ring. Look for this. If this carbon is this particular position is number 1 carbon, this carbon and this one is carbon. If I will take like this is cyclopropane. If I will try to rotate, the bond will be broken. If a group will be placed over this, then both group is on the same side. But if a group is placed over this and another group is placed over this, then both group are on the opposite side. So orientation of group in space are different. In first case, both groups are on the same side. But in second case, both groups are on the different side. So orientation of atom or group in space are different. So in case of sigma bond, you must remember that in rings, there is restriction in rotation. So for a molecule to show geometrical isomerism, first condition is molecule must have restriction in rotation. Second condition is if a molecule have restriction in rotation, that means it must have some restricted bond. It must have some restricted atoms. So second condition is this restricted atom must have different substituent. It may be possible this has A, B. It may be possible this has C and D. That means A double bond B, A have different substituent, B have different substituent, then such molecule will show geometrical isomerism. Is it clear to everyone?
Yes, sir.
So there are only two conditions for a molecule to show GIE. First condition is molecule must have restriction in rotation, and second condition is restricted atoms must have different substituent. If molecule fulfill both these two conditions, then such molecule will show geometrical isomerism. Is it clear?
Sir.
Yes, sir.
Now write in notebook condition for geometrical isomerism. Write it. Conditions for geometrical isomerism. Simply GI. Condition for GI. First, molecule must have molecule must have restriction in rotation. First, molecule must have restriction in rotation. And second, restricted atom. Second, restricted atom. Restricted atoms must have different substituent. Different substituent. The first condition is molecule must have restriction in rotation, and second condition is restricted atoms must have different substituent. Is it clear to everyone? Is it clear to everyone? Now, human body have one thing most important. Most important. What is this? What is this? Which is most important? Which make human body, which makes human being most dominating. What is that? What is that? Is it hand? It is leg? Is it mouth, eye, ear, or brain? What is most important?
Brain.
Very good. Brain is important thing which makes human body, human being superior over all the animals present on this earth. All the animals present on this earth. Think for the human body. Humans are more fear to small cheetah, small ant. They get fear in ant. They get fear in all the animals on this earth. They fear in dogs, cats, ant, everything. They cannot fly, they cannot swim, but many animals have inbuilt property to swim, inbuilt property to fly. But human body have brain. By using this brain, they can practice and make shapes from which they can go from one place to another place. On this brain, they make rockets from this India to any other place. So most important thing is brain. So brain. Use the brain. There are two concepts. There are two important points. The condition, molecule must have restriction in rotation, and second is restricted atoms must have different substituent. The medical is the examination of this brain. Medical is the examination of this brain. So many questions arises which to check your mental ability or brain. So if molecule have restriction in rotation, the question arises. There are carbon-carbon double bond. There are carbon-nitrogen double bond. There are nitrogen-nitrogen double bond. There are carbon-oxygen double bond. There are carbon-sulfur double bond. There are carbon-phosphorus double bond. It may be possible. There are oxygen double bond. There are sulfur-oxygen double bond. There are sulfur-sulfur double bond. It may be possible. It has carbon-carbon triple bond. It has carbon-nitrogen triple bond. It has nitrogen-nitrogen triple bond. If first condition is molecule have restriction in rotation and pi bond have restriction in rotation, so pi bond may be of any type. Pi bond may be of any type. The question arises, all these conditions will show GI? No. That's why this second condition arises. Molecule must have, restricted atoms must have different substituent. That means at least two substituents are present. So here, if I will make this A, if I will make this B, this carbon have different substituent. If I will make this A, this B, even I can make C and D. The A have different substituent, B have different substituent. That means molecule will show GI. Is it clear to everyone? Is it clear to everyone?
Yes.
Here, think for this. If I will take A, if I will take B, the A have different substituent. Think for this. Nitrogen has one lone pair of electron. This has bond pair of electron. That means B have different substituent. Substituent may be of lone pair, may be a bond pair, no matter. The A have different substituent, B have different substituent. That means this will also show GI. Here, nitrogen has lone pair, nitrogen has bond pair, nitrogen has lone pair, nitrogen has bond pair. A have different substituent, B have different substituent. That means this will show GI. But in case of carbon oxygen double bond, think for this. Here, two lone pairs are same. If I will make the change in A and B over this C, if I will create a change over this C, A and B, but we cannot change over this oxygen because both lone pairs are same. If we have same substituent or same lone pair, then such compound will not show GI. Is it clear? Is it clear? Tell me.
Yes, sir.
Here again, if I will make A, if I will make B, there is a difference over this carbon. But again, this sulfur has both lone pair same. And both lone pair same, that means this will not show GI. Here again, if phosphorus is having 5 bond, then molecule will not be planar. It will be sp3 hybridized. So sp3 hybridized, that means no GI. Here again, oxygen has lone pair same, oxygen lone pair same, that means no GI. Oxygen has lone pair same, sulfur have lone pair same, that means no GI. Here again, lone pair same, lone pair same, that means no GI. In case of triple bond they are linear. Triple bond they are linear. For a molecule to show GI, they must be planar. They must be planar so that we can easily say that these two groups are same side or these two groups are on different side. But if they are linear, we cannot say that both groups are same or both groups are on different side. So any triple bonded system will not show GI. Any triple bond system will not show GI. So now question arises, how many places this GI will be possible? The first is along carbon double bond carbon. Is it clear? First is along carbon double bond carbon. Second is along carbon double bond nitrogen. Third is along nitrogen double bond nitrogen. Is it clear? Is it clear?
Yes, sir.
For a molecule to show GI, first case is along carbon double bond carbon. Second case is along carbon double bond nitrogen. Third case is along nitrogen double bond nitrogen. So write it in notes form. So write general cases of geometrical isomerism so that your notes will be completed and you can easily do question on the basis of that notes or important points. Write it. General cases of geometrical isomerism. Write it. General cases of geometrical isomerism. First, along carbon double bond carbon. First, along carbon double bond carbon. This particular has A, here B, here A, here B, or it may be possible all the groups are different. First, along carbon double bond carbon. Second, along carbon double bond nitrogen. Second, along carbon double bond nitrogen. Carbon double bond nitrogen. Any group or atom may be present over this position. Third is along nitrogen double bond nitrogen. Third is along nitrogen double bond nitrogen. It may be possible both groups are same. It may be possible both groups are different. Both groups are different. Is it clear? Is it clear?
Yes, sir.
The first case, tell me, first case along carbon double bond carbon. Second case along carbon double bond nitrogen. Third case along nitrogen double bond nitrogen. Is it clear? Is it clear? Concept is A double bond.
Yes, sir.
Good. Concept is A double bond B. A have different substituent. A have different substituent. B have different substituent. It may be possible all the four groups are different. A have different substituent. B have different substituent. E have different substituent, B have different substituent, E have different substituent, B have different substituent, E have different substituent, B have different substituent. Is it clear? Is it
Yes,
clear?
sir.
Yes, sir.
Now you have said that cyclic system also have restriction in rotation. So fourth one is along cycloalkane. Along cycloalkane. Cycloalkane. In cycloalkene, it may be possible both groups are nearer. It may be possible both groups are apart from each other. But it is important, it must have at least 2 carbon which have different substituent. It has at least 2 carbon which have different substituent, It may be AB, it may be AB, it may be C or D. Again, E double bond B, E double bond or ring B. E, this is B. E have different substituent, B have different substituent. Is it clear? Is it clear? So when you
Yes, sir.
think for cycloalkene, this carbon is sp3. This carbon is sp3. It is important. It is important to remember. When you think about cycloalkane, at least 2 sp3 carbon. At least 2 sp3 carbons are present which have different substituent. Once again, I'm saying this. When you think about cycloalkanes, then in that case, at least 2 sp3 carbons, are present which have different substituent. If molecule will have condition like this, fulfill the condition of this, then that molecule will show GI. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
Take the example so that your concept will be enhanced. Think for this molecule. Think for this molecule, whether this molecule will show GI or not. This molecule will show GI or not. How many hydrogen are present over this carbon? Tell me.
2.
How many hydrogens are present over this carbon? Tell me.
2.
2. Very good. 2. Here, 2 hydrogens are present. How many hydrogens are present over this carbon? Tell me.
2.
2.
2.
2 hydrogen. 2 hydrogen. How many hydrogens are present over this carbon?
2.
2.
2.
Both carbon, all carbon have 2 hydrogen. All carbon have 2 hydrogen. Is it clear? All carbon have 2 hydrogen. Now think for this. I've said that at least 2 sp3 carbon and 2 carbon have different substituent. But in first case, here both hydrogens are same. 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 So molecule do not have any sp3 carbon which have different substituent. So this molecule will not show GI. Is it clear? Is it clear? Now think for this molecule. Think for this molecule, methyl cyclohexane. Whether this molecule will show GI or not. What you will say? What you will say? This molecule will show GI or not?
Not.
No, because two sp3 carbons are needed which have different substituent. 2 sp3 carbon 1 and 2 sp3 carbons are needed which have different substituent. This molecule has only 1 carbon which have different substituent. But other carbon have same substituent, hydrogen and hydrogen. Other carbon have same substituent, hydrogen and hydrogen. So this molecule will not show GI. Is it clear? Is it clear? Tell me.
Yes, sir.
Now think for this molecule, beta. Think for this molecule. If I will have 1,2-dimethyl cyclohexane, 1,2-dimethyl cyclohexane, whether this molecule will show GI or not?
Yes, sir. GI.
Yes, because here 2 sp3 carbon have different substituent. This carbon has hydrogen methyl. This carbon has hydrogen methyl. The condition in cycloalkane is at least 2 carbon must be there which have different substituent. at least 2 carbon must be there which have different substituent. That means this molecule will show Gi. So this molecule will show Gi. It means that it has 2 possibility. It means 2 possibility. One possibility is both alkyl groups are on the same side. Both alkyl groups are on the same side. Second possibility is one alkyl group is above the plane and second alkyl group is below the plane. Is it clear? Is it clear?
Yes, sir.
Any molecule which will show Gi, it simply means that it will exist in more than one form. Any molecule will not show Gi, that means it will exist only in one form. It will exist only in one form. No isomer of this molecule is possible. No isomer of this molecule is possible, but 2 isomers of this molecule is possible. Both have same IUPAC name, 1,2-dimethyl cyclohexane, 1,2-dimethyl cyclohexane. But stereochemistry of this molecule and stereochemistry of this molecule are different. In first case, both methyl groups are on the same side, but in second case, both methyl groups are on different side. So stereochemistry of first and second are different, but IUPAC name are same. So they are stereoisomer and they are the stereoisomers of 1,2-dimethyl cyclohexane. Is it clear to everyone? Is it
Yes,
clear to
sir.
everyone? Now,
Yes, sir.
one important thing, beta, which you must remember. First, fifth is along cycloalkene. I will take many example to make your concept clear. First, write about the cases where geometrical isomers are possible. So there are 5 cases. First is along carbon double bond carbon. Second is along carbon double bond nitrogen. Third is along nitrogen double bond nitrogen. Fourth is along cycloalkene. And fifth is along cycloalkene with carbon greater than or equal to 8. If you are going to think about cycloalkene, that means double bond present inside the ring. Double bond present inside the ring. In that case, number of carbon will be 8 or greater than 8. If number of carbon is 8 or greater than 8, in that is only cycloalkene will show Gi. Is it clear? Is it clear? Tell me. Is it clear?
Yes, sir.
Now,
Yes, sir.
now
Yes,
once again, make a concept. When I'm saying about cycloalkene, that means I am saying for sp2 carbon. I'm saying for sp2 carbon. And when I'm saying for cycloalkene, I'm thinking for or saying for sp3 carbon. So when you are thinking for sp3 carbon, that means 2 carbon must have different substituent. But when you are thinking for sp2 carbon, the number of atoms in the ring will be 8 or greater than 8. This is why. Why? What is the reason behind this? The reason is this. If I will make a double bond, if I will make alkyl group, I will make alkyl group in the same side. So there is easy possibility of overlapping, and there is formation of bond. But when I will try to make overlapping over this carbon and this carbon, so minimum carbon requirement is 8. If number of carbon is 4, then the overlapping of this carbon orbital is not possible. So I will increase the number of carbon by 5th. Distance again not appropriate. If I will increase the carbon 6, again distance not appropriate. But I will make a carbon 7, it will become closer. But if I will make carbon 8, then it is more appropriate to form a bond. To make cycloalkene, minimum carbon is 8. If it is 8, then that is opposite form will also exist along with this type of structure will also exist. That means if the number of carbon is 8 or greater than 8, there is possibility of two structures. But if the number of carbon is less than 8, like this, if I will make double bond over this position, all will be same. Is it clear to everyone? Is it clear to everyone? Tell me.
Yes, sir.
You can also think like this. You can also think like this. If this hand is carbon-carbon double bond, carbon-carbon double bond. If a alkyl group over this, if alkyl group over this, you can easily make a bond and make a cyclic system. Make a cyclic system. But if a alkyl group in this side, if alkyl group this side, the distance is very far apart, so that overlapping is not possible. Overlapping is not possible. So you have to increase the number of carbon. 1, 2, this is 3, this is 4, now this is 5th, this is 6th, and here this is 7 and this is 8. Now they are appropriate position to make a bond. Is it clear? Is it clear?
Yes, sir.
Now,
Yes, sir.
now to make two structures along carbon double bond carbon in cyclic system, at least 8 carbon or 8 atom in the ring must be there. Is it clear? Is it clear?
Yes,
Yes,
sir.
sir.
Now think for this molecule. Think for this molecule and report your answer. Whether this molecule will show GI or not. Tell me. Whether this molecule will show GI or not.
No, sir.
No,
No,
very
sir.
good, very good. Because E double bond B, A have different substituent, B have different substituent. But in this case, carbon have both hydrogen same. Carbon have both hydrogen same. So this molecule will not show GI. Condition for GI: molecule must have restriction in rotation. Restricted atoms must have different substituent. Think for this. Think for this molecule: CH3, CH double bond, CH2. What you will say? What you will say? This molecule will show GI or not? Tell me. Snath.
Yes.
Tell me. Manju. Ramya. Tell me.
Yes, sir.
Abir. Yes sir. No. Think once
No.
again. Think once again. This will show GI or not? Look for
No,
this.
sir.
Look for this. Look for this carbon. Look
No,
for this
sir.
carbon.
No,
This
no,
carbon.
No, sir.
Yeah,
No.
yeah. Once again, this carbon has hydrogen and methyl. This and have different substituent. But this carbon has hydrogen. This and have same substituent. So molecule will not show GI. Molecule will not show GI. Think for this molecule: CH3, CH double bond CH. Here again CH3. Think for this molecule, whether this molecule will show GI or not.
Yes.
Yes, sir.
Yes, sir.
Yes.
Yes.
Very good, very good. Because this particular carbon has H methyl. This particular carbon has H methyl. So this and have different substituent. This and have different substituent. That means molecule will show GI. Molecule will show GI. That means it will exist in two forms. One form will be like this. Another form will be like this. Is it clear?
Yes, sir.
Yes,
Yes, sir.
Any molecule will show GI. That means only it will exist in more than one form. Any molecule that will not show GI, that means it will exist only in one form. If I will give some question and ask to find out whether the molecule will show GI or not, can you do that? Can you do that?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, I'm taking some example. Try to solve this. Try to solve this. Write on your notebook too. Write on your notebook too and try to find whether a molecule will show GI or not. Write on a notebook and try to solve. Try to solve. Find the molecule which will show geometrical isomerism. Try to solve whether the molecule will show geometrical isomerism or not. Dio, Sanya, Avanya, Arjun, Adriya, Aved, Hari, John. Is it clear? Can you do the question? Ramya, Rich, Snath. Try to solve the question, beta. Swetha. Svetlin. Anyone who have done the question? Anyone? Tell me. First 4 question. Have you done? First 4 question. Have you done?
Yes, sir.
Yes,
now,
sir.
now tell me whether the first compound will show GI or not.
No, sir.
Not. No.
Very good. Very good. Because hydrogen are same. Hydrogens are same. This will not show GI. Is it clear to everyone?
Yes,
Is
sir.
it
Yes, sir.
clear to everyone?
Yes,
Good.
sir.
This will not show GI. What about this?
No, sir.
No, sir.
Very
No,
good.
sir.
Because hydrogens are same. It will not show GI. What about this?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Very good. This has hydrogen, this has methyl group, both are different. Again, this and have hydrogen, this have methyl, both are different. The E have different substituent, B have different substituent, that means this molecule will show GI. Very good, very good. These 2 questions you have already seen. These 3 questions you have already seen in this example. This example, clear? Now, main question comes from next part onward. Think for the 4th one. This molecule will show GI or not?
Yes, sir.
Yes, very good.
Yes, sir.
This particular carbon is hydrogen and methyl. This particular carbon is hydrogen and ethyl. So this and have different substituent, and this and also have different substituent. That means this will show GI. Now try to solve 5th to 8. Try to solve 5th to 8. Then I will discuss it. Have you done? Have you done the question? Snark says only 6 will show GIE. Snark says only 6 will show GIE. Tell me whether this 5th compound will show GIE or not.
No, sir.
No, very good.
No, sir.
Very good.
No, sir.
Because
No,
this
sir.
carbon has both hydrogen same, so no GI will be possible over this carbon-carbon double bond. Here again, this is CH2, not CH3. This particular carbon has both hydrogen same, so no GI over this carbon-carbon double bond. So no GI over this carbon-carbon double bond, no GI over this carbon-carbon double bond. That means molecule will not show GI. Is it clear to everyone?
Yes, sir.
Yes, sir.
Now,
Sir.
think for 6th one. Think for 6th one. Whether this molecule will show GI or not.
Yes, sir.
Yes.
Yes, sir.
Along,
Yes, sir.
along
Yes, sir.
carbon-carbon double bond first or
Yes, sir.
carbon-carbon double bond second or both. Which carbon-carbon double bond will
Second.
show GI? First one or
Second.
second one or both?
Second one.
Second one. Very good. Because in second one, hydrogen and here vinyl groups are present, and here hydrogen and here methyl groups are present. But in first, hydrogen are same. So no Gi over this carbon-carbon double bond. There is Gi over this carbon-carbon double bond. It means both hydrogens are on opposite side. It means both hydrogen may be on same side. Structure may be like this also. Is it clear? Structure will be written like this. Structure will be written like this. Two possibilities are there. If a molecule will show Gi, this will show Gi. Think for this molecule. Think for this molecule, whether this molecule will show Gi or not. Tell me, whether this molecule will show Gi or not.
Yes, sir.
Yes, sir.
Yes, very good. Very good.
Yes, sir.
Very good. This nitrogen has lone pair of electron. This nitrogen has bond pair of electron. This particular has different substituent. This carbon has hydrogen. This carbon has methyl. This and also have different substituent. If this carbon also have different substituent, this nitrogen have different substituent, that means it will show Gi. One possibility is that both methyl groups are on the opposite side. One possibility is that both methyl groups are on the same side. Is it clear? Is it clear?
Yes, sir. Yes, sir.
If a molecule will show Gi, it simply means that it will exist in more than one form. Now, think for 8 to 10. Think for 8 to 10. Then I will discuss the question. First, write it on your notebook, whether the compound will show Gi or not. Whether the compound will show Gi or not. First of all, think for that. Take time, because correct answer is more important than fast answer. Have you done?
Yes, sir.
Yes, sir.
Now, think for the 8th. Whether 8th compound will show Gi or not. What do you will say?
Yes, sir.
Yes, sir.
Yes, sir. Very good. Very
Yes.
good.
Sir.
Very good. Because this nitrogen has lone pair, bond pair, different. This nitrogen has lone pair, bond pair, different. That means this molecule will show Gi. In one case, both alkyl groups are on opposite side. It may be possible in another case, both alkyl groups are on the same side of restricted bonds. There is possibility of existence in of two types. Now, think for 9th. Think for 9th, whether this molecule will show Gi or not.
No, sir.
No, sir.
No, very good.
No.
Very good. Very good. Because this particular carbon has both methyl same. This particular carbon has both hydrogen same. This particular carbon has both methyl same. This carbon has both hydrogen same. This carbon has both hydrogen same. So in case of cycloalkane, at least 2 sp3 carbon with different substituent must be there. But here, this condition is not fulfilled. Therefore, this molecule will not show Gi. Good. What about 10th? What about 10th? Whether this molecule will show Gi or not?
No, sir.
No, sir.
No,
Sir.
no,
No,
No, sir.
no.
Don't think fastly. Take some time and think for this. Take some time and think for this.
Yes.
Think for the concept. Once again, think for the concept. In case of cycloalkane, I said that at least 2 sp3 carbon, at least 2 sp3 carbons must be there and they have different substituent. And in case of cycloalkene, where carbon is sp2 hybridized, I said at least 8 carbon in the ring. Think for this. If you will think for this carbon-carbon double bond, if you will think for this carbon-carbon double bond, that means sp2 carbon. So number of carbon in the ring is 5. So there is no Gi along this carbon-carbon double bond. But think for the cycloalkane. This particular carbon has methyl hydrogen different. This particular carbon has methyl hydrogen different. This particular carbon has methyl and hydrogen different. This particular carbon has methyl hydrogen different. The system, cyclic system has 2 sp3 carbon. Cyclic system has 2 sp3 carbon which have different substituent. That means this molecule will also show GI. Is it clear to everyone? Is it clear to everyone? Tell me.
Yes, sir.
Yes, sir.
Once again think for this. Take the example like this. I'm making 5-member ring like this. I will make CH3 over this position. And if I will ask whether this compound will show GI or not, what is your answer? Whether this compound will show GI or not, what is your answer? This compound will show GI or not? What you will say?
Yes.
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 Yes, it will show G.
This will show GI. That means this molecule will exist like this. Both methyl group will be on same side. It will also exist like this when one methyl group is above the plane and another methyl group is below the plane. Is it clear? Is it clear?
Sir.
Think for
Yes,
this.
sir.
Think for this like this. Think for this. This is 4-member ring. 1, 2, 3, 4. I have taken another carbon like this. This is 5-member ring. One methyl group I am taking here. One methyl group I am taking here. Both methyl group are on the same side. Now I am taking methyl group over this above the plane and now taking methyl group below the plane. Both are different. Both methyl groups are on the opposite side. Here both methyl groups are on the same side. Orientations are same or different? Same or different?
Different.
Different. Now think. If I will make a double bond over this position, whether there is any change in orientation, tell me. Whether there is any change in orientation, here both methyl group again above the plane. Here one methyl group is above the plane, another methyl group is below the plane. So no matter whether it has carbon-carbon double bond or no carbon-carbon double bond. If system is cyclic and two carbon is sp3 hybridized and have different substituent, that means following this condition and it will show GI. If along carbon-carbon double bond, I said number of carbon is minimum 8. Is it clear? Difference is clear to everyone?
Yes, sir.
Yes, sir.
Difference is clear? Now think for 11 to 13. And write your answer. Once again, I'm saying that for sp3 carbon, when you are looking for sp3 carbon, at least 2 sp3 carbon with different substituents are needed. And when you are looking for sp2 carbon, at least 8 atoms in the ring must be present. Think. 11 to 13. Have you done that? Take time. Should I discuss? Should I discuss? Manju, John, Arjun, tell me, should I start discussing? Discussion?
Yes, sir.
Yes, sir.
Now think for 11. Whether this 11th compound will show GI or not.
Yes, sir.
Yes, sir.
It will show.
It will show. Very good. Because along carbon double bond carbon, there is only 5 carbon in the ring. So no GI over this. But along sp3 carbon, along cycloalkane sp3 carbon, 2 sp3 carbons are required and both have different substituent. 2 sp3 carbons are there, both have different substituent. Both have different substituent. That means it will show GI. Very good. Now think for 12. Think for 12 whether this molecule will show GI or not.
No.
No.
No,
No,
very
sir.
good, very good. Because along carbon double bond carbon, there is only 5 atom, 5 carbon in the ring. And for cycloalkene, where 2 sp3 carbons are required, which have different substituent. Here, only 1 carbon, sp3 carbon are there, which have different substituent. Another carbons have 2 hydrogen same. So there is only 1 carbon have difference. So this molecule will not show GI. Now, think for 13th.
Yes.
Yes or no?
No.
No, sir.
No, because along cycloalkene, there is 5 carbon. Again here, only 1 carbon, 1 sp3 carbon have difference. These two carbon have same hydrogen substituent, hydrogen present. So there's only difference at only 1 sp3 carbon, no difference at other sp3 carbon. So it will not fulfill this condition. So this molecule will not show GI. Is it clear?
Yes, sir.
Now,
Yes, sir.
now do this question. Do these 2 questions and think for your answer. Do these two questions and write your answer. Whether these 2 molecules will show GI or not. Should I start discussion?
Yes, sir.
Now,
Sir.
now,
Yes, sir.
now, give your answer. Whether this 14th compound will show GI or not.
No,
No,
sir.
No.
No,
No.
sir. No.
Very good, very good. Because this carbon-carbon double bond will not show GI because there is only 5 carbon in the ring. This carbon-carbon double bond will also not show GI because again ring have only 5 carbon. That's why these 2 will not show GI. And here this carbon has sp3, but there is only 1 sp3 and requirement is 2 sp3. So this molecule will not show GI. And what about this molecule 15th?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Yes, sir. On the
Yes, sir.
Very good. Because along this carbon-carbon double bond, there is limitation of 8 and here only 5, so not so GI. But at least 2 sp3 carbon and here 3 sp3 carbon and all have different substituent. So GI may be possible from this side also, GI may be possible from this side or this side also. Any GI from any side, that means molecule will show GI. If I will ask question from this basis, can you solve correctly? Tell me.
Yes, sir.
Yes, sir.
Yes, sir.
You have seats of resonance, modules of resonance, and if you do not have modules of resonance, then on ResoSir app, you can look over there. There is a PDF, and from that PDF, you have to solve the question related to geometrical isomerism. I will also share on this platform, Telegram channel, I will share the PDF if you do not have that. And I will make a WhatsApp group, and on that WhatsApp group also I will share. And this class lecture will be shared on my YouTube channel also. Okay, so that you can revise more than one time to make your understanding more crystal clear. Okay.
Okay.
Okay, sir.
Have you enjoyed?
Okay, sir.
Have you enjoyed today's class?
Okay, sir. Yes, sir.
Yes, sir.
Yes, sir.
Should I close today's class? Any doubt regarding today's lecture?
No, sir.
No, sir.
No,
No,
sir.
sir.
You have to
Yes, sir.
make two notebook, beta. You have to make two notebook. One notebook for theory, which you will study in June classes, and second notebook for question, which you will have to do for DPPs or seeds. So that if you do more practice on the question, your subject understanding will be enhanced. Okay.
Okay, sir.
Now
Yes,
Yes,
sir.
sir.
I'm closing today's class, and we will meet in the next class.